We all know that mathematics is a tool used in all subjects, whether it be science or art. Very few people know that the use of algebraic constructs as a tool in science, nature, or art is far overreaching. Algebraic construct is a structure of algebra derived from various other concepts. Their uses are great importance in everyday life. We all use negative numbers in our everyday life. Did you know that negative numbers are also algebraic constructs? Have you ever asked yourself that if the product of two positive numbers is positive, then the product of two negative numbers will be negative? This asymmetry is not natural, but it's introduced by mathematicians to make a number jump by 180 degrees on a number line, hence changing the direction. Now that's the actual reason why the product of two negative numbers is equal to a positive number. This property allows an accountant to represent negative balance with negative numbers in red, and also allows photographer to sharpen an image using Laplacian filters. However, imaginary numbers are even better tools and as real of a construct as negative numbers. Rennes Descartes came up with the term imaginary numbers, while Carl Gauss came up with the term lateral numbers to represent change in direction. You can visualize a number whose square is -1 when moved laterally. Just check out this formula of impedance in an AC circuit. Since voltage equals current times the impedance, it is known that voltage across capacitor lags the current, while voltage across inductor leads the current. Before we get into our final example, let's discuss natural numbers. Now, natural numbers are just positive integers. These are described as natural because, as we just saw, negative numbers, or imaginary numbers for that matter, are created by humans for the real world to work with, for example, temperatures or signal processing. However, the most powerful algebraic construct of all is a number such as e taken to the power of an imaginary number. This tool makes it simple to visualize difficult concepts such as Fourier transform or path integral. Take the identity e to the power of ix, where e is a natural logarithm. For any function of e, the slope of the function will be the same as the function value. So when you raise e to an imaginary number, you have to move it into the imaginary plane. However, e being natural, the graph just keeps moving in circles. Take a look at this Fourier transform graph. The frequencies that superimpose the circular motion are present in the series. This is because at any point in the circle, the rate of change of an angle is directly proportional to its current value. As can be seen, negative numbers, imaginary numbers, and natural logarithms are created by humans for real-life purposes. Do remember that these are only a few examples of algebraic constructs. More discoveries can be made by mathematicians to make life more easier and more efficient.